Okay, so we're starting inequalities today. Very similar to what we've done with equations, but there are some differences. Starting with the basics, with all the symbols that we're going to be using. Greater than, less than, greater than or equal to, and less than or equal to. I know this isn't new to you, but please make sure you see the difference between the two. The way I see the difference is when I read something from left to right, which I've talked about quite a bit. When I start from left to right, I get to the bigger side first. This one's greater than. When I start from left to right, I get to the smaller side first. This one is less than. That's how I remember it. I know there's lots of other shortcuts where, you know, the bigger side eats the bigger number, anything like that. That's perfectly fine as long as you see the difference between these symbols. So going on with basics today, I want you to be able to write the inequality when you're given a graph, and then graph an inequality when you're given the inequality. So the first example we have here, I want you to notice with the graphing here, please do not, when you graph something, do not take 10 minutes and go 0, 1, 2, 3, -1. This is a waste of time, guys. You do not have to do every single one. It's not going to benefit you in any way. So you can see how my graphs are. This is kind of the expectation. I typically put 0 in there and whatever other number I'm graphing, and that's enough. You know, don't spend time on things that aren't worth it. So the first one, we need to figure out what the inequality is that's graphed here. So very informally, who can tell me what numbers are being highlighted on this number line? Jack?
-3 and 0.
More than that. That's a good start. Dylan?
-3, -2, -1, and 0.
What about 5?
No.
Go ahead, quick.
Everything in front of -2. So like,
To the right.
yeah.
So this arrow indicates everything is going in that direction. That means
Greater.
that 1,000 is included, 3 million is included. What about 253?
Yep.
Absolutely. How about -0.25?
No.
Absolutely, because it would
Oh,
be
wait, yeah.
right here. Anything to the right of -3. What about -3?
Yeah.
It is
Yes.
included because the dot is filled in. That's important to note. So this one's going to be x is greater than or equal to -3.
Okay.
That means anything that is -3 and bigger is included in this graph. So that arrow is showing you anything that's bigger. 3 trillion, 3, 9.75, anything that's to the right of -3. Okay, for this one, look at the difference between example 1 and example 2. This one has a completed dot. This one has a hollow dot. What do you think that means? You?
Not including the, in this case, highest number 5.
It does not include 5, but everything's smaller. So this hollow dot, not filled in, that means that 0.499999999 is included, but 5 is not. 0.4999783 whatever. That's included, but 5 is not. So everything to the left of 5 is included, and that would look like this. We're always using X. My symbol always points in the same direction as my graph. I do not put a line under it because it's a hollow dot, and I use the number that has the dot on it. So this is, X is all the numbers that are less than 5. Look how I did this one up here. Always start with your X. Look how my symbol is pointing in the same direction as my graph. There's a line under it, which means that that -3 is included. Does that make sense?
Mm-hmm.
Okay, let's go in the opposite direction. So I need to show on a graph all numbers that are smaller than or equal to -1. If you can look at this inequality and interpret it into everyday words, that's helpful, like what I just did. It's all numbers that are smaller than or equal to -1. So again, with my graph, put a 0 on there. Typically I put 0 in the middle. And I know -1 is somewhere over here. That's all you need on your graph. Because it has a line under it, that means you're going to fill your dot in on -1. So a solid dot. And my graph is gonna point the same direction as my symbol. So my symbol is pointing to the left, my graph points to the left. Which means any number that's smaller than -1. -1.5, -5, -36, -92. Anything that is to the left of -1 is being highlighted. So the couple of things you need to remember. The dot goes where the number is. It's completed dot or filled in dot if the line is under it. And the symbol points in the same direction. Let's do another one. Start with my graph. I'm going to put a 0 in the middle. I'm going to put 5 on my graph. So because there is no line under it, that means that 5 is not included, which means I have a hollow dot. So that hollow dot goes on 5. My graph points to, or my symbol points to the right, so my graph also points to the right. So I'm highlighting anything that is bigger than 5. 5.001, which would be like right here. 5.8, 9, 3,000, 3 million, 9 trillion. Everything that is to the right of 5 is included. So let me stop there for real quickly. Any questions on writing the equation or the inequality or graphing the inequality? Anything that I didn't make clear here?
So it says, oh wait, now I get it.
Okay, well remember, we're gonna practice this and I'm here to help you if you need it.
Or, actually now I have a question.
Go ahead.
So it says x is greater than 5, but then why is 5 pointing the other direction?
That is greater than. So 6 would be here, 7, 8,
X is
9,
unknown.
10, 50, 3,000. It's pointing to all the numbers that are bigger than 5.
Oh, I thought x was like 0.
Well, we don't know what x is. X is our answer, which will, the direction we're going in is defining what our answer is. In the past, we said x is 4, x is 93, whatever. In this case, you're gonna have a whole set of numbers that can work instead of just one number, okay? Okay, moving on to graphing, or solving and graphing. We're gonna solve these exactly the same way as we did equations. These are one step. The only difference is what I have in red up here. The only difference. When you have addition and subtraction like this, nothing's different. When you're solving, and the process of solving, if you multiply or divide by a negative number, you flip the sign. That's the only difference. So I'll show you that in just a second here. So the first problem, we're going to do the exact same thing as what we did before. Our goal is to get to multi-step inequalities. This is one step. So we're going in that direction. So we draw our line. Instead of down the equal sign, we draw our line down the inequality symbol. We're always going to show our work. This is one step. Again, we're going in the direction of multi-step. Remember those questions we asked in December? To get the x by itself, what do I make go away? That -4. What's the 4 doing now?
Subtracting.
It's subtracting. What's the opposite of subtracting? Adding. So that's how I make it go away. Whatever goes on the left must happen also on the right. So I'm going to add 4 to both sides. Bring down my x. Bring down the symbol. 3 plus 4 is 7. So be careful because we've done so many equations that you don't write equals, because x doesn't equal 7. X equals anything less than or equal to 7. So let's do a graph of this. Put our 0 in the middle and put a 7 somewhere to the right of that. Is my dot going to be solid or hollow?
Solid.
Solid, because we have a line under it. And my graph will point to the left because that's how my symbol is pointing. So if you look at my graph, it says anything to the left of 7, anything smaller or equal to 7. Will 7 work?
Yes.
Will -85 work?
Yes.
Absolutely. Anything to the left, remember, -1, -2, -3, -4, -10, -80, -95. Anything to the left or smaller than 7. So let me prove to you why that works. Give me a number, Dylan, give me a number smaller than 7. Any number you can think of.
-21.
Okay. So according to our solution and our graph, -21 is a solution. So let me plug it in and see if it works. We're saying x could be -21. Let's see if this makes a true statement. So I picked a solution and plugged it in. Let's see if it works. This is our keep, change, flip. Keep, change, flip. What is -21 plus -4? -25. Is -25 less than or equal to 3?
Less than.
Absolutely.
Yep.
That's a true statement. It works. Does that make sense?
Yes.
If we picked any number, as long as it's smaller than 7, it would work. Let's do one more. So for this one, again, we're gonna draw our line. We have two sides of our inequality. We need to get rid of the -2 to get x by itself. Remember those questions that we asked?
Mhm.
The -2 is being multiplied, so how do we make the -2 go away?
Divide by -2.
We divide by -2. Whatever we do on the left, we have to do on the right. What I just wrote is our exception from solving equations to inequalities. If you divide by a negative number, you must flip your sign. That's the only time you flip your sign. Notice that I did not flip the sign here, but I did here. So if in the process of solving, you multiply or divide by a negative number, you flip the sign. Everything else stays the same. Over here, the -2's cancel, and I have x left. On the right, what's -10 divided by -2?
5.
+5. So it's right here that caused me to flip my sign. It's not your answer, it's what you're doing. So let's graph this. Put your 0 in the middle, put the 5 on the right-hand side. Is this a filled in dot or a hollow dot?
Filled in.
Filled in, and it's gonna point to the left. My symbol points to the left. My graph must also point to the left. So this graph and this solution says any number that's smaller than 5. Give me a number that'll work.
-3.
Yep, -3 will work. Give me another number.
4.
4 will work. Give me another one.
2.
Good. Good.
-100.
Oh, I like it. Good.
5.
Good.
-5-ish.
Good.
3.
Good.
-225.827398.4.
Awesome.
-89,000 trillion.
Awesome.
There, 12.
Good.
-25.
Good.
-70.
And we could do this all day.
6.
It's any number that's smaller than 5 will work in this original inequality. All of those numbers that you guys all said, if I multiply those numbers, each of those numbers by -2, I will get a number that's less than or equal to -10. That's what that means. Okay? Go ahead and stop.
Okay.